again, today we're going to look at inductive, deductive reasoning. One thing that mathematics has, it requires thinking. So sometimes some careers out there ask you to take a high math class just to see if you can think. Before as a doctor, they took up to calculus 2, but it's just to see if they can think. And they're not going to operate using formulas and everything. But if I go to the hospital and I get operated on, I hope the doctor can think. So that's why we're going to look into thinking. There's two types of reasoning, inductive, deductive. The first one is going to be inductive reasoning. It's a logical process in which multiple premises, all believed true or found true most of the time, are combined to obtain a specific conclusion. In fact, thinking is such important and a little bit hard in college. For those of you who are going to go to college, you're going to take a thinking class. It's called philosophy. It's all about thinking. Inductive reasoning is a logical process in which multiple premises, all believed true or found true most of the time, are combined to obtain a specific conclusion. What this mumbo jumbo says, the premise is basically what has happened, what we're going to use for thinking. So using most of the time sentences, we're going to believe they're true, we're going to come up with a conclusion. As an example, 2 Mondays ago it didn't rain. In Bakersfield, it didn't rain 2 Mondays ago. Last Monday it didn't rain. Today's Monday, it's not raining. So I'm going to assume, based on that, I'm going to assume next Monday is not going to rain. As a matter of fact, that's what the weather, in the news, weather people, that's what they do. They look at what has been happening, and they say, oh, it's not going to rain. They give you guys percentages. 10% chance of rain. That's almost 0, so obviously it's not going to rain. Right? 90% chance of rain, more likely it's going to rain. If I come over and say something about 50, there's a 50% chance of rain tomorrow. 50 means yes or no, so that means I don't know. Right? So sometimes when you look at the news and they say 40 or 60% chance of rain, that means they don't know. That means that they don't know. One time I actually saw 50% chance of rain. And I'm like, 50 means yes or no, you know nothing. At least say something like 40 or 60. But that's what they mean. Whenever it's around 50, that means they don't know. Whenever it's close to 0, that means it's not going to happen. Close to 100 means yes. So for next Monday, I would say I'll give a 99% chance of no rain next month, based on what has happened on the last month. Could I be wrong? Probably. It could rain. We never know. You guys have tried the food here. Whether you liked it or Wednesday, I'm pretty sure Thursday was the same, Friday was the same, today was the same. So I'm going to assume, if you like our food here in the cafeteria, if you like it, I'm going to assume you're going to like it tomorrow. If you don't like it, I'm going to assume you don't like it tomorrow. Because it has been the same. Would it taste the same? Who knows? What if they fire everybody today, and they hire new staff, and then they cook it? Was it going to happen? More likely not. That's it. Let me take a look at another example. Don't have to copy my example. But what we tried in inductive, in math, in geometry at least, the way we usually test you is in numbers and patterns. So let's take a look at some numbers. First one I come up with 15, then 13, 11, 9. What do you guys think I write next? 7. And then 5, and then 3. Because you guys noticed each time I was subtracting by 2. Could I come in after 9, go crazy, and be like, no, let's try, instead of subtracting, let me start adding? Well, I could. But more likely, I'm not going. Like when I test you guys, I would switch it like that. All right, I showed show you guys a pattern, and I expect you guys to be able to see the pattern and continue. Sometimes it will be numbers, sometimes it will be figures, and things like that. Alright, let's talk about a conditional statement. So let's copy that thing down. The conditional statements are in the form if, dot, 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 then, dot, dot, dot. Conditional statements are in the form if and then. Matter of fact, conditional statements, they have a lot into it, so I'm not covering it just yet, but some other geometry teachers are covering it, and I know you guys talk to your friends, they might be taking geometry with somebody else. If they have like biconditional, converse, inverse, and all that, that comes from conditional statements, which I'm not covering just yet. So they come out with words like that, that's something that. But a conditional statement, as the word says, is the first word, condition, right? Condition is like, I ask you to do something, and if you do it, then something else happens. A conditional statement, let me give you guys an example. If you pass geometry, then you will go to this one. So my condition, you guys, once again, don't have to copy this example. If you guys do, it's fine. I give you a condition. You pass geometry. That's the condition I'm giving you. And if you do it, then there comes a reward. You go to this one. Kind of like your parents come and tell you, if you wash dishes, then you can watch TV. Right? There comes the reward. Right? That's what we call the conditional statement. The condition is not always at the beginning. Because I could come and say, that word, that sentence, I could rephrase it as, you will go to Disneyland if you pass geometry. So see, I can switch it around. So the if part is the condition, the then part is the reward. Okay. Now that we know what a conditional statement looks like, let's talk about deductive reasoning. It's a logical process in which a conclusion is based on the concordance of multiple premises that are generally assumed to be true. Most of our time in deductive reasoning, our premises are conditional statements, or at least one conditional statement, most of the time. Deductive reasoning is a logical process in which a conclusion is based on the concordance of multiple premises that are generally assumed to be true. Deductive reasoning is a logical process in which a conclusion is based on the concordance of multiple premises that are generally assumed to be true. So remember, inductive, we're looking mainly patterns. That's mainly what it was, patterns. Deductive is based on information given to it. An example, let's go back to the conditional statement I gave earlier. If you pass geometry, then you will go to this and that. Let's say you come over and you get a B in geometry, which is passing. What do you think will happen? You will go to this, right? If I give you a conditional statement and you complete the condition, then there comes a reward. Once again, that's deductive reasoning. But let me switch this a little bit. Let's say I come and give you the same conditional statement. If you pass geometry, then you will go to this and that. But then you go to this and that. Can we conclude something from that? You went on your own. That's basically what we conclude. You went on your own. You don't really, just because you go to Disneyland doesn't mean you pass geometry. Right? The reward was given, but doesn't mean that the condition was true. So if I switch it around, you cannot conclude the condition happened. Alright, let me practice a little more on deductive. Let me give you guys a couple statements, not always conditional. The football team has a game on Friday. Paul is a member of the football team. What can we conclude from that? What is it? Paul's a member of the football team, and but what else? football game on Friday. Right? The team's playing. Paul's part of the team, so Paul has a football game on Friday. All right, let's take a look at another one. All cars have four wheels. Honda CR-V is a car. What can we conclude from that? A Honda CR-V has four wheels. So you guys see what deductive happens, right? Sometimes a conditional statement, sometimes it's not quite. Okay. Then let's learn the law of syllogism, which is also called logical chain. This is part of deductive. And geometry states that if P then Q and if Q then R, it's also possible to derive a third statement that is P then R. Just copy the mumbo jumbo and then I'll explain it. P, Q, and R for statements up here. P, Q, and R are phrases. Right? If you do something, then that happens. It's just that as mathematics, we're not that creative, so that's why we use letters. Keep in mind though that one statement, one of my statements, the first statement finishes in Q, then the next one starts with Q. Once again, P, Q, and R are phrases. Notice that on the last one, I'm omitting Q. So if the ending of one statement is the beginning of the other, I can combine both statements by writing the beginning of the first one and the ending of the last one. Does that make sense? So let me say that again. If I have two statements, and the ending of the first one is the beginning of the second one, I can combine my two statements by writing the beginning of the first one and the ending of the last one. And I'm going to omit what they share. Let me show you guys an example. Can I take this off right? Alright, let me show you guys an example. First, let me write it like this. You don't have to copy it, let's just look at it. If you wear yoga pants and violate the dress code, you will need to go to the office. If you go to the office, you will need to change your clothes. To make it more easy for us to see, let me color some of the words in there. You notice how the ending of one, you will need to go to the office, it's the beginning of the other one. Let me combine my two statements into one, and I will just write, if you wear yoga pants and violate the dress code, then you will need to change your clothes. See how I combine it by writing the beginning of the first statement and the ending of the last one. And I omitted what they both share. Right? It was a little bit hard at the beginning when everything was in black, but keep in mind I color it so we could see it. And once again, the way I combined it was the beginning of the first one and the ending of the last one. I only have two statements here, but the law of syllogism, I could have many statements. And then put them in order, and the way you will combine them will be the beginning of the first statement and the ending of the last one. And so we'll take a look into it in our homework. So let me just take a look at the homework already. The front side, I want us to practice inductive. And inductive is just patterns. I have some numbers patterns and some figure patterns, but it's just patterns. I'm just asking you guys to complete the next number. And as quiz, I could ask you guys, give me the next number. I could give me the next three. But it's just a pattern. Any questions on the front? Okay. Let's see where that. What do you guys get for number 6? Some of my patterns are easy to follow. Some of them are not quite easy to follow. Let me help you guys a little. I noticed from the first number to the second one, I added 4. Then I added 9. From 14 to 30, I added 16. Then I'm going to add 25. Then I'm going to add 36. How much do I add next? What is it? The first one I added 4, then I added 9, then I added 16, then I added 25, then I added 36. You guys don't recognize those numbers? To help you guys a little, they're perfect squares, nice. So, no, not quite.
49.
We're going to add 49. Because if you notice, each time where we're adding was 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So let's add 7 squared. So we're going to add 49. So now what do we get?
140.
Not 1.
130.
140, yes.
That's 32.
Okay, so 140, okay. So see, some of the patterns were easy to see. I'm pretty sure number 1, 2, you guys can do those. Some others were not that easy. What is it? 2 is hard? Alright, let's take a look at number 2. The first one I added 2. Then I add 4. Then it's 8. Then 16. Then 32. So each time I add twice as the previous time. Right, whatever I add each time was twice of what I added the last time. We could do that. So if each time I add twice of the previous one, how many am I going to add the next time? We're going to add 64. So then you guys can complete the number. Right? Each time we added twice as much as the previous time. Remember I said that thinking sounds like a nice verb, but it's not that easy to do. Alright, any other questions from the front? Okay. Alright, let's take a look at deductive, which is going to be on the back. Question number 1. I will go to the game if I get all my homework done. Keep in mind, my if is not at the beginning. The conclusion is not, the condition is not at the beginning of the sentence. Then I get all of my homework done. So I complete my condition. What can we conclude? I will go to the game. If I give you a condition, you do the condition, then we can assume the reward comes on. If I give you a condition, but you do the reward, then we can just conclude that you did the reward. Alright, let me erase this. Let me scroll down a little bit to questions 4 through 7. Instructions say that let's assume that these 4 statements are true. Like, let's assume they always happen. Alright, if Dad goes shopping, then he will buy a pretzel. The mall's open, then Jody and Dan will go shopping. And then every time that Jody goes shopping, she buys a pizza. And today the mall's open. So let's assume that that is always true. For number 4, did he buy a pizza?
No.
So false, right? It's true. So let's say it's false. And it says explain, at the end, explain your reasoning. I'm going to say he bought a pizza.
Wanted a pretzel or bought a pizza?
Oh my bad, a pretzel. Just checking it your way. Not that I make mistakes. Just check out you guys are awake. Alright, so he bought a pretzel. In geometry, or in thinking, in logical thinking, a false statement doesn't mean it did not happen. A false statement means I don't quite believe it. Right? We don't know if Dan actually went and bought a pretzel and a pizza. We know he bought a pretzel. Once again, a false statement doesn't mean it did not happen. It just means I don't quite believe it. I'm not quite sure. That's what in mathematics, that's what a false statement is. I'm not quite sure, so I'm going to say it's not true. Once again, he bought a pretzel and a pizza. I'm not quite sure he bought a pizza. Okay. Jody had some of Dan's pretzel. Are you quite sure? So then it's false. Remember, in geometry, if you're not quite sure, then we call it false. Remember, false doesn't mean it did not happen. I'm just saying I'm not quite sure. All right. So explain your reasoning. What can we write for explaining?
Jody didn't mention.
Well, Jody had some of Dan's pretzel. Okay, but why can we not say, because we said false, why can we not conclude that Jody had some of Dan's pretzel? But just because I bought a pizza doesn't mean I cannot have some of your pretzel. Just because he bought a pizza doesn't mean quite that he just wanted a pizza.
Dan wanted a pizza.
We don't even know. We don't even know if they know each other. If I go shopping and someone else goes shopping, at the mall I see a lot of people, doesn't mean I know them all. Right? Someone goes shopping, someone else goes shopping. So to begin with, we don't even know if they know each other. And even if we knew they know each other, we don't know if they share food.
So 5 would be false.
5, Jody and Dan went shopping.
That's true.
That one is true. The mall's open and they go shopping when the mall opens. Which one? In this case, yes. Alright. Now let's take a look at the bottom part. I'm going to practice some of the laws of syllogism. And remember, syllogism, the example was the first sentence, the way it ended, that's how the next one started. Alright, so for us to find which one happened first, because it says arrange each of the statements to form a logical chain, for me to find out which one happened first, the beginning of that sentence, it's not the end of any other sentence. So that's basically how the first one happens. The beginning of that sentence is not the end of any other sentence. So which sentence from the 3 I gave you, it's not the beginning of it, it's not the end of any other.
C is first.
So C comes first.
C and then it's A and B.
So see how C started with winter, and none of the other sentences ended with it's winter. So that's how we know that one came first. C ends with the days are short. So now, which other sentence starts with the days are short?
B.
B. And I noticed that B ends with it is cold. Which other sentence starts with it is cold? A. So we put them in order. We're going to arrange each of the statements to form a logical chain. We put them in order, and then write the conditional that follows from the logical chain. Conditional statement, right? Write the conditional statement, and then I told you guys that for us to write the conditional at the end, I'm going to write the beginning of the first sentence, and I'm going to write the end of the last one. So the way I will write this will be if it is winter, the beginning of the first sentence, and then the end of the last, then birds fly south. you write the conditional statement, the way you combine them all, you write the beginning of the first sentence and the end of the last one. Alright, so I'll let you guys practice with number 9. Just for you guys practice syllogism. Once again, mathematics is not all about numbers, it's about thinking, especially in geometry. So for tomorrow, we'll have our first project. Projects are actually worth more than a worksheet. And a worksheet or assignments, I usually help you guys, right? I do some examples, and then if you guys have questions, I answer them. So I help a lot on the worksheets, but on the projects, I don't. I might show you a similar project, and what I mean with a similar project, I do something that has some relationship to your assignment. For tomorrow, we're going to come out with formulas. Like you guys know formula, like the quadratic formula, the slope formula, all the formulas. And I'm going to show you guys how I come out with a formula. So this is for tomorrow. I'll show you guys how I come out with a formula. Then I'll ask you guys to come out with the formula for something else. However, my formula and your formula have some relationship. But that's for you guys to find out. On the worksheets, I help you. On the projects, my only hint will be think. So if you guys come over to me and then ask you for help on your project, I will just come back and look at you and say think. Since thinking requires more process than any other worksheet, I'll let you guys work in teams. Up to 4. So don't make a team too big. Up to 4. That means you can work by yourself if you wish. Since you're choosing your team tomorrow, make sure you choose people that work with you. If you pick somebody because that's your friend, and that friend of yours is lazy, then it's your fault to pick up that way. So don't pick a person just because they're your friends, because if you do, and they're lazy, it's your fault. So don't come and complain to me later. You can work by yourself if you wish, or with somebody, up to 4 people per team. Like I said, we'll do that. We're going to call it high five. You know what a high five is, and we'll work with it. And once again, the projects, you require more teamwork.